In this lesson, we're going to tackle an idea that is maybe the most useful application of the derivative. Some of you probably know that I studied economics in college, and I use this idea absolutely all the time. It's this notion of the extreme values of a function. So we've already studied maximums and minimums in the past. Here we're going to use the derivative to justify where these maximums and minimums are a little bit more rigorously. I want to start by just introducing this idea that we have at the top of the page here. This is called the extreme value theorem, and it's not super profound, to be honest, but as always, we like to give things names so we can use them to justify our ideas later. So this says that if a function is continuous on some interval from a to b, then it has both a maximum and a minimum on a to b. So all that means is that if I can draw a nice smooth unbroken line between 2 points, that line is got to have a top and a bottom essentially. So I drew some pictures here for your notes to help illustrate this. So here is A is our minimum, and then we have a maximum at the top of the curve here in my first example. In the second one, we have a maximum and then a minimum here. And then my third example, this is an example of a function that is not continuous, and it just illustrates to show like why we need to say a function is continuous, right? So in this example, it has an asymptote and the function goes up and up forever. So we wouldn't say that it has a maximum on that interval. So we'll come back to that extreme value theorem a little bit later, but the reason I bring it up is to illustrate this really important point. Sometimes, right, our maximums and minimums occur at the edges of that interval, right? So the endpoints of the interval, in addition to the middle. Okay, we're going to see that in our nuts and bolts example here in a second. So what we have here is a stocks example, right? And with stocks, it's obviously useful to know where the maximum and minimum prices are, right? Because that's where you want to buy and sell them to make the most money. So we're going to start by finding a maximum price of this stock when the price is given by this function s here. And we're going to use an idea related to the derivative that we've kind of teased before, but we've never explicitly used so far in this course, and that's that at a maximum, and here's an example from before, at a maximum, a function has a horizontal tangent line, right? So if I want a maximum of s, well, I can set s prime of t equal to 0, and that's going to help me find that point. So that means I take a derivative, and then I set my derivative equal to 0, and I just did power rule here, and then I'm going to factor. I'm going to leave that 0.2 chilling, and it's okay if this one's like a little bit harder for you to factor, because it is on the harder side. You could also use a calculator to find your zeros, right? And remember I said I wanted to set this equal to 0. Well, this is going to spit out 2 points. If I do the math here, I get 5 halves as my t. And then 18 from the other one, obviously. So notice I found 2 points. I don't necessarily know which one is the maximum, because one of these could be a maximum and one of these could be a minimum. I don't know what the curve looks like. So what I'm going to do is I'm going to take a look at the table of the values of this function. So I typed in my derivative in my graphing calculator, and what I see, right, is it looks like the function is positive from 0 to 5 halves, and then negative until 18, and then positive again after that. So this allows me to draw a sign chart for my derivative, right? And I could have done this by hand as well, but the calculator is just going to be a little bit faster. So let's fill out my sign chart here, and then we'll think about what it means. So we got positive, and then negative in the middle from 5 halves to 18, and then positive again. So remember, this is my derivative. We'll label it s prime of t. So what this means, right, is s is increasing, decreasing, and then increasing again. Well, in my little sketch up here, my maximum was this point, right? So it looks like I'm going upwards to its left, downwards to its right. So we want the point where the function goes from increasing to decreasing, and that is here, right? So I would say my maximum occurs at 5 halves, And then we also ask for the value of the stock at that time. Well, the value is given by S, right? So I want S of 5 halves, which I can just plug in on my calculator to my original function, not my derivative, and I get 251.458. And obviously I'm talking about dollars, so 2 places make sense, but it's 3 places for the AP Calc exam. Now I want to write a little AP style justification for this before I move on to the next one. So I'd say at t equals 5 halves, S has a relative maximum because, and I'm going to include 2 things here. First, the derivative is equal to 0 at that point, and because it switches, the derivative switches from positive to negative. Okay, so that's my full justification. That would earn me full points on my exam. Now the question is, what is the absolute highest value the stock attains in February? Now this is a little bit tricky, right? Because we found a maximum, but is it the absolute maximum, the highest of all of them? To tackle this, we're going to go back to this idea here. So remember when I drew my little sketches up here? A maximum could be, or a minimum could be at the endpoints, or at a spot where the derivative is equal to 0. So let's take a look at the graph of S here. So this is the graph of my original function S. I typed it in, and I had to do a little bit of playing with the window. So I went from 0 to 28 because we're talking about February. February has 28 days, and that's given in the text as well. And then my Y value, I find I get a good picture from 0 to 500. So here's what my graph looks like. And we can see, right, that the function takes its highest value here at the end of the time interval, right? So if I had used my relative maximum, my 5 halves, that would be over here. That would be wrong, right? If I sold my stock there, I'd be missing out on money because it actually is worth more at the end of the month. So if I wanted to investigate this without a calculator, I would use what is called the candidates test. So I'm going to make a little table here and I'm going to check candidates. So what that means is I'm going to check my endpoints. So that was here, right? 0 and 28. And I'm going to check the 2 t's I got over here where my derivative is equal to 0. So that's 5 halves and 18. And then I can plug all these values into S because I know that the absolute highest value has to be either where the derivative is equal to 0 or at the endpoints. And I'm getting these values just by plugging them into the function S on my calculator, right? And what we find is exactly what we saw on the graph. So this is not a surprise to us at this point, is that my maximum occurs at this endpoint. So I have to check everywhere where my derivative is equal to 0 or these endpoints, these boundaries of my function. So these 4 values are my candidates, just like candidates for president or something like that. They're my candidates for a maximum. The last thing we're going to add here, is just how to justify either a relative maximum or a minimum, which is what we found in the first question, or an absolute maximum or minimum on the AP exam. So they're looking for something specific to back up their reasoning. Okay, for a maximum or a minimum, a relative maximum or minimum, that's what we did here, right, for our first question. So we say that the derivative is equal to 0, and then say that the derivative changes signs from positive to negative, that's for a maximum. Or the opposite would give us a minimum, obviously, right? So this is an example of finding a maximum or a minimum and how you would justify in the AP exam. For an absolute maximum and minimum, that's what we did here, right? So the absolute maximum and minimum, we're actually going to make a table. And that table is going to be all the critical values, so that's where the derivative is equal to 0 is a critical value, and the endpoints of the interval, right? So it's just like we did in our second example. And then we're obviously going to pick the biggest or smallest one, and we'll describe the maximum from our table, and we're going to say then by the candidates test. So it will reference this test as if it's a known thing, and they're going to know what you're talking about. Okay, so the idea is not super complicated. We're going to do a little bit of practice a bit later in the module of writing these justifications correctly.